Now that we've covered the key functional programming concepts and features found in modern Java, including function composition, avoiding side effects, and immutable objects, it's time to put all the pieces together in the context of case study ex2. Part 1 of this case study examines ex2's overall structure and functionality, focusing in on the SequentialStreamFactorial class implementation. This implementation can be found in the ex2 project, in the FP folder, in my modern Java GitHub repository. We're now in the IntelliJ project for case study ex2. This program implements 4 ways of computing factorials for big integers to demonstrate the correctness and performance of different parallel and sequential algorithms that use immutable or mutable Java objects. It also shows the dangers of sharing unsynchronized mutable shared state between threads and the overhead of excessive synchronization of shared mutable state. Java sequential and parallel streams are used in this program to compose both pure functions and functions with side effects. Let's now dive into our analysis of case study ex2's source code by first taking a look at the fields defined in the ex2 class. The first field is called smax iterations. It's a static final int that defines the total number of iterations to run the timing test, and we set this value to 20,000. The next field is called sDefaultN, which is also a static final int, which defines the default factorial number to compute, which we set to be 1,000. Let's now take a look at the main entry point into the test program. This method begins by initializing the factorial value to compute to either sDefaultN or to the value of argv sub 0 that was provided on the command line by the user. Next, we go ahead and warm up the threads in the Java common fork join pool so that the timing results will be more accurate. And then finally, we run the 4 factorial tests. The first test that we run is called SequentialStreamFactorial, and it provides a baseline factorial implementation using a Java sequential stream that does not leverage multiple cores. Next, we run the buggy factorial test, which shows how the race conditions can occur when a mutable shared state that's shared between threads in the Java common fork join pool use a Java parallel stream and the Java for each terminal operation. The third algorithm we analyze is called synchronized parallel factorial, and this shows how Java synchronized methods can inefficiently avoid race conditions when state is shared between threads in the Java common fork join pool. And the final algorithm we look at is called parallel stream factorial, and this shows how the reduce operation in the Java parallel streams framework eliminates shared mutable state between threads in the Java common fork join pool. Each of these particular tests is timed, as we'll see shortly, and when we're done, the main method prints the timing results in descending order from fastest to slowest. Before we analyze each of the algorithm implementations, let's take a look at the run test helper method. This function runs the given factorial test function, which is passed as a parameter, to compute the factorial of the parameter n, record the time needed to compute this value, and then it will print the results of doing the factorial computation. The first thing that this method does is it runs the garbage collector to ensure each test starts out with access to all available memory. Next, we go ahead and time the test using the runTimer helper class, which records how long methods take to execute and prints the results ordered from fastest to slowest execution times. The methods that are timed are stored in a results map, which keeps track of the method name and the time taken to execute each method. The runnable passed to the timeRun method is defined here as a runnable lambda, which uses an int stream to iterate smax iteration times, which is essentially a functional for loop, and each iteration applies the factorial algorithm, passing in the parameter n. You can see here that we've also passed the algorithm name to the timeRun method, so it can store that name as the key in the underlying results map. After all the executions have been run, we then go ahead and apply the factorial algorithm one more time and print the results. Now that we've walked through the structure and functionality of the main method and run test method in the ex2 class, let's turn our attention to the implementation of the SequentialStreamFactorial class. This class is nested inside the immutable state class shown in the immutablestate.java file here. This file contains classes that use Java objects with immutable state to compute factorials for big integer objects. The SequentialStreamFactorial class provides a baseline factorial implementation using a Java sequential stream that doesn't leverage multiple cores on a multi-core processor. This class contains a factorial method that returns the factorial for the parameter n using a Java sequential stream and the reduce terminal operation. This method is quite straightforward. It uses the long stream range closed factory method to create a stream of longs from 1 to n, and then it goes ahead and it converts each long value in the stream to a big integer. And finally, it computes the factorial by performing pairwise reductions on the elements in this stream. It passes in big integer 1 as the initial value to reduce, and it also passes in the big integer multiply method as a method reference which plays the role of the accumulator, which actually performs the pairwise multiplication on the elements in the stream until we end up with the final reduced result, which of course is the factorial of n. You'll note that there's no shared mutable state in this example, but it's also only running in one thread, and therefore won't be able to leverage the inherent parallelism in modern multi-core processors. So we're now done with part 1 of our case study ex2, which walked through the SequentialStreamFactorial class implementation and gave an overall view of the structure and functionality of the ex2 case study.